What? It was? I knew it. There's no way that was double-sided tape. That had to be used gum. Okay, thanks. I'm going to switch from transposition to substitution types. We're going to start with the Caesar shift cipher, named after Julius Caesar, who used it to correspond with his generals. The common view is that he used a shift of 3 so that A is equal to D. It was also popularized with the secret decoder rings that used to be packaged in boxes of breakfast cereal. Now, we can speed up manual encryption and decryption by using a cipher wheel or slide. The disadvantage of a slide is that because the letters don't wrap, we need to double up on one piece of the slide or the other in order to compensate for wrapping. I'll meet you in the training room. Encryption. You can easily find Caesar wheels or cipher disks on the net. Slides are easy to make. Just print the alphabets on 2 strips of stiff paper and cut slots for the narrower strip to slide along the wider one. By convention, the outer or upper alphabet is used for placing the plaintext letters and the inner or lower one for the cipher letters. With this convention, if we say that A equals E, then with a wheel, rotate the inner disk so that E is under A. I'm using a slide because it's easier to animate and because that's all we had the budget for. So with the movable slide, E is placed under A. Both approaches work the same. For the text, this is a text message. We place the letters on the outer disk or upper slide and take off the letters from the other disk or slide. Conversely, we could number the offset, that is 4, and count off that many letters to the right. From A, B, C, D, E, 4 letters. I'll demonstrate this idea with the decryption phase. Regardless, we get, for the key A equal E, the following slide. And the ciphertext is XLMW, MW, E, XIWX, QIWWEKI. And we're done with encryption. Decryption. There are a couple of different ways to handle decryption for Caesar shift. We could just count off the shift in the alphabet to the left instead of the right. Or with a wheel or slide, set the key for the encryption A equal E, look for the cipher letter on the inner disk or lower slide, and read off the plaintext from the outer disk or upper slide. Or we could use a reversed key, such that E equals A, and go through the same process we did for encryption. All 3 approaches give the same results, so use the one you feel most comfortable with. Using a simple numeric offset, A equals E was the same as adding 4 to each letter. So for decryption, just subtract 4. We take the first letter X, go 4 places to the left, we get T. We take L, we go 4 places to the left, we get H. We take M, go 4 places to the left, we get I. W, 4 places to the left, we get S. Continue. And we recover our plaintext message. Using the slide or a wheel, we could just do the reverse of encryption. Set A equals E, place the cipher letter on the lower slide or inner wheel, and read the plaintext letter off the upper slide or outer wheel. I'll let you practice that on your own. For the reversed key, the thing about Caesar shift is that it is reciprocal. That is, we can take a message enciphered with A equal E and encipher it again using E equal A to get the plaintext back out, as follows. That's it. Use whatever approach feels best for you. Omake, solving Caesar shift ciphers. I don't really like doing this since it's like giving away product for free, but this is a really short video as is, and Caesar shift is the basis of one of the most powerful cipher types, Vigenère. The following description will be useful later on. All written languages have fingerprints. That is, there are certain letters that are used more frequently than the others. And this letter frequency information is a strong tool in solving many kinds of ciphers, as well as in identifying the language the cipher was written in. Let's use the following text, which is a quote of what I just said for decryption. I'm not going to repeat this. It's 425 letters long, and the 9 most frequent letters are E appearing 67 times, T 42 times, O 38 times, and then R, H, S, A, I, and L. I got etor sale, which is close to the normal pattern of ETOAIN SHRDLCU, or etoin Schurdklu. The important point to keep in mind is that the actual letter distributions you can expect to see will depend on the text you analyze. Military manuals will give different results from a work of modern fiction or a medical textbook. With a large enough sample base, we expect to see roughly the following letter percentages. E appearing at the top at 12.7% of the time, T 9%, A 8%, O 7%, and then continuing down to U at 2%. And then all of the other low-frequency letters will be between 1% and nearly 0. Naturally, we can use letter frequencies to solve Caesar shift ciphers too. The graph here shows the same English letter frequency distribution in alphabetic order. The following cipher is a quote from one of the books by Stephen K. Zoltan-Brust. I pinned it in the comments below. I'm not going to read the cipher text. It gives us this distribution. L appears 23 times, Z 10 times, V 9, A and P 8, and then it goes down from there. Comparing the distribution for our crypt to our earlier normal graph, we want to look both for peaks and valleys. The peaks for L, A, and Z are pretty much spot on for E, T, and S respectively. And the values at Q and X line up with those for J and Q. Connecting the data points for each graph, we can see the similarity in patterns a little more clearly. So what happens when we shift our graph 7 places to the left? Answer: we get our key. A is equal to H. Pause here if you want to solve this cipher yourself. Decrypting this cipher as described earlier, we get:
most people seem to take pleasure in feeling superior to someone. I'm not like that, which pleases me because it makes me feel superior.
If you want to try your hand at solving Caesar shift, I pinned a few practice scripts in the comments below. If you want to learn one more method for solving Caesar shift, which will be very useful for tackling Vigenère, you can join the Black Chamber on Patreon to get access to the next video when it comes out, or wait until it goes public on YouTube sometime later. That's enough for now. See you at the next drop point. Got questions, comments, or suggestions? Leave them in the comments below. Enjoyed this video? Then I encourage you to hit the like button and subscribe to this channel. If you want to show further support, you can join us over at the Black Chamber Patreon page, where you can get access to more how-to videos and PDFs on solving the cipher types covered here, additional crypts to solve, and more. Links pinned in the comments below. See you at the next drop point.